Hello, calculus students. In this problem, we're going to approximate the area under the curve x sine x over the interval from 0 to pi over 2 using the following points: 0, pi over 6, pi over 4, pi over 3, pi over 2. So we're going to approximate the area under the curve. So we're going to approximate this integral. We'll use a left point approximation and a right endpoint approximation. So here's the left endpoint picture. And here's the right endpoint picture. Now I'll show you how to set up the problem, but I will actually leave the computations up to you. Now notice in the left endpoint approximation, you start at the left endpoint, which is 0. And so you have to compute the area of this rectangle, which turns out to be 0 in this case. Let's just go through putting in the numbers anyways, okay, so we get good at that. Now, you have to compute the width of this subinterval, okay, which gives you the base of this rectangle. Now notice in this case, clearly that's pi over 6. But the width of this rectangle is not pi over 6. Instead, it's pi over 4 minus pi over 6, which is not pi over 6. So the bases of these rectangles are not uniform. They're not the same, okay? So let's call this one delta x1. Let's call this width delta x2. Let's call this one delta x3. And let's call this one delta x4. I'll leave that to you to compute. And the first one will be pi over 6 minus 0. For this one, delta x2 will be pi over 4 minus pi over 6. Delta x3 will be pi over 3 minus pi over 4. And delta x4 will be pi over 2 minus pi over 3. Okay, so I'll leave that to you. Now to get the heights of these rectangles, you plug them into the function. That will give you the y value, because the height is given by the point on the curve, the y value. So in this first case, it's going to be 0 times sine of 0. That'll give you the height, and you multiply that by the base, and that'll give you the area of this rectangle. So the first one, the first rectangle, will be base delta x1 times height, which is 0 times sine of 0. Then we will add the base of the next rectangle, delta x2 times the height, and the height is the function evaluated at pi over 6. Delta x of 2, delta x of 2, pi over 6 times sine pi over 6. Plus, so we have this rectangle. We already calculated the area of this rectangle. We need the area of this rectangle. That's delta x3 times the height, which is the function evaluated at pi over 4. So that's pi over 4 times sine pi over 4 plus, oh, that was the area of that rectangle. Now we need the area of this rectangle. That's delta x4 times the height of this rectangle, which is the function evaluated at pi over 3. So that's delta x4 times the function evaluated at pi over 3. And that gives you the area of this rectangle. So you have to compute those bases, compute the values of the functions, add them all together, and you get the approximate area under the curve, which looks something like that. Okay, in this case, things are slightly different. So be careful. The height of this rectangle is given at pi over 6, so your first one's evaluated at pi over 6. Notice that it is not at pi over 0. So the width of this rectangle we call delta x1. The width of this one we call delta x2. The width of this one we call delta x3. And the width of this one we call delta x4. So you get the same widths, but you got to be careful. You're not multiplying them by the same heights. So in the first case, it'll be delta x1 times the function evaluated at pi over 6. plus, okay, so we have the area of this rectangle, delta x2 times the function evaluated at pi over 4. So that's delta x sub 2 times the function evaluated at pi over 4. Plus, okay, so now we have the area of this rectangle. We need the area of this rectangle. That's delta x3 times the function evaluated at pi over 3. Plus, okay, now we have the area of this rectangle. We need the area of this rectangle. That's delta x4, the base, times the function evaluated at pi over 2. And that gives us the area of this rectangle. So, here's the approximation. You have to figure out delta x1, x2, x3, x4, and the values of the functions, and that will give you the sum of the areas of these rectangles, which is this overestimate of the area under the curve. Now notice the differences here. This is delta x1 times pi over 6 sine pi over 6. Here you have delta x1 times 0 sine over 0. Here you have delta x times pi over 4 sine pi over 4. Here you have delta x2 times pi over 6 sine pi over 6. So see the contrast between this line and this line? This one, the pi over 6 times sine pi over 6 is multiplied by delta x2. And this one, the pi over 6 times sine pi over 6 is multiplied by delta x1. Here, the pi over 4 times sine pi over 4 is multiplied by delta x2. Here, the pi over 4 times sine pi over 4 is multiplied by delta x3. Here, the pi over 3 times sine pi over 3 is multiplied by delta x4. Here, the pi over 3 times sine pi over 3 is multiplied by delta x3. Then you have the rightmost endpoint. So be careful when you look at the differences between the two. There's a shift. Here you get an overestimate, here you get an underestimate. Okay? Once you sum up those areas of those rectangles, you will get the approximate value of this integral over these points. Good luck.